right, this is a Thevenin, and also we're going to use a Thevenin to achieve maximum power. Right, so this is a max power problem. Determine the Z load that will allow maximum power to be delivered to the load in the circuit below. Now remember, maximum power is when max power when the Z load is set equal to the Z Thevenin or the complex conjugate of the Z Thevenin. Right, and so the complex conjugate is reflected on the real axis. So that means that if whatever my Z load is, if it looks like this, then the Z Thevenin complex conjugate would be plotted like that along a real imaginary axis. Okay, so what we need in order to achieve that is we need to get to the Z Thevenin. How do I do the Z Thevenin? The first step is I remove the load. So for Z Thevenin, I1, remove load, and I2, zero the source. So if I wanted to redraw this, I remove the load, there's A and B. Across here's the inductor, the resistor, and the capacitor. There's the inductor, there's the resistor, and I zero the source. Well, zero current looks like an open because no current can flow through. Zero current flows through an open circuit, so it's open. Now for the Z Thevenin, I look back. Let me do it in red. Right, so for Z Thevenin, I'm looking back between, it's the total impedance between A and B. Well, this one up here isn't included because in order to get from A to B, there's no way for it to go through there. This one is also not included. So to get from A to B, it's not included. So inside of that is everything that it takes to get from A to B, so the total impedance. Well, what does that look like? We'll call that the Z equivalent, but it's between the nodes A and B. And so we have 10J is paralleled with 20 minus J30. The way that I would write it is just like that. I would write minus J30, but then I would write it on my paper, 2.5 plus J 12.5. But in my calculator, if you wanted to know how I would type it, how do I keep doing it? Does anybody have a Surface Pro to know how the best way to get rid of that is? No. Nope. It keeps happening. Hit escape, does it work? There we go. Okay. Sorry about that. So if I was writing on my calculator, I would do the fraction button like this. And then I would do it again. 1 over 10J plus 1 over 20 minus J30. Remember that would be an I in your calculator, but I would write it all as one big formula. And that way I can make sure it matches to what I just said. 10J is paralleled with 20 minus 30J. So there's my Z Thevenin. So determine the Z load that will allow maximum power to be delivered. Well, that is the Z Thevenin. So therefore I take that complex conjugate and I say Z load would be equal to 2.5 minus J 12.5. And that is the Z Thevenin that would achieve. But then it says find the power dissipated by the load. Well, now in order to find the power maximum, if I look at the equation sheet, it says E Thevenin squared over 4R Thevenin. Well, I don't know E Thevenin, so let's do that in orange up top. Whenever I do E Thevenin, all I do for E Thevenin is I remove the load. And remember, E is a voltage. So the way I'm going to do it is I'm going to remove the load right here and just look at it like that, right? And then looking back from here, I'm looking for the voltage from A to B. That is the E Thevenin, right? Because it's the open node voltage. So I've removed the load. So from node A to node B, what is that voltage drop? This kind of goes to what I said earlier about series parallel. Well, these things, if I was to use a voltage divider rule or an Ohm's law, I would need to make sure that what I'm talking about is between A and B. So this current, 500 milliamps, goes up, goes through the 24 ohm, and then it divides up. So I could find a current divider rule and then multiply that current by one of those. The other way I could do it, which is what I'm going to do, is I'm going to put those in a box. There's my current source. There's my inductor. There's a box that I just drew in orange. There's the resistor. And now that 500 milliamps is what flows through that box, right? Here's A and here's B. Well, note that this is the same box that I drew earlier, so I can actually just call it that Z equivalent. Note that those two boxes match between A and B. It doesn't always work out. It does work out here. That's how circuit analysis works, that I analyze it and say, oh, those match, I'll just use that. So I use V equals IZ. The voltage from A to B is the current going through from A to B, which is 500 milliamps angle 0. The Z is that Z equivalent, 2.5 plus J 12.5. And the voltage from A to B is 6.37 volts, angle 79 degrees. That is my E Thevenin. So now I can plug those into my Pmax equation. And we'll do Pmax in blue, right? So Pmax in the bottom right is just the magnitude of the E Thevenin. So it's just 6.37 squared. 4, and then it's just the R Thevenin. So it's only 2.5, right? Up above where it says the R Thevenin. Well, this is R Thevenin, and this is saying plus J X Thevenin, right? So there's the 4 over 2.5, and the P max that can occur is 4.06 watts. And there's my two answers that were asked.